Welcome to zebracode.io, and we are on lesson 7. We're going to be doing demo 2, so I'm going to create within my lesson 7 folder demo2.py, and let's get some practice working with random numbers. And that's a function, or that we can import random, and that's importing all of this functionality available in this random module. And I can say for x in range 5, so I'm going to do this 5 times, and I'm going to print random.randint, and random integer returns an integer between these endpoints, including the endpoints 1 and 6. So this is simulating a dice, and I'm going to roll it 5 times, and let's go ahead and roll it 5 times, and we can do that by doing Python 3, and we'll do demo2.py, and that's where we just wrote this code, and we get this dice that we've rolled 6 times, 1, 2, 3, 4, 5, or we rolled it 5 times, and as you can see, we got different answers. So let's do the same idea. Random integer is a very simple idea, and let's try to apply this basic concept to something a little bit more complex. Let's see how many rolls it takes. I'm going to be rolling 2 dice until I get all possibilities with 2 dice. And so, for example, when I roll 2 dice, I can get something as low as 2, or I can get something as high as 12. And so let's think about this, because that's the basic idea as we baseline our code. And what are the possibilities? Well, we can get 2, 3, 4, 5, all the way up to 12. And let's count the number of possibilities there are. So the possible rolls are 2, 3, 4, 5, and we can go all the way up to 12, and we see that there are 11 possibilities. Between 2 and 12, including the endpoints, there are 11 possibilities. Now, of course, we know that the most common is going to be 7, so if we roll this many, many times, we're going to get 7 many times. But we want to see how many times it takes to get all of these possible rolls all the way from 2 to 12. And so we're also going to need a count, and let's initialize count equal to 1, and we can kind of experiment. So the main idea here is that we want to test for membership, and every time we create a roll, we want to store that value in a list. So I'm going to call it rolled. That means once we've rolled it, then I will append it to this list, but I'm going to start off by having an empty list because I haven't rolled anything less. Now here's the key idea. On line 8, we have to think, well, the length of the roll, is it less than or equal to 12? How do we want to do this? We know there's 11 possibilities. There's a lot of thought that can go into it, but probably the best way to think of it is if there's 11 possibilities, we can say, well, the length of rolled is not equal to 11, because we're going to start off with 0, and then we're going to have 1, then we're going to have 2, then we're going to have 3. And so the best way to think of it is while rolled is not equal to 11. And so let's change this. While length of rolled is not equal to 11. So the idea is we have a list called rolled, and each time we roll something, if we append it to that rolled, and then we can create a count. Now let's go ahead and flesh this out. Let's roll, each time we're going to roll 2 dice. So one die 1 will equal random integer between 1 and 6. So that's going to represent 1 die. And the second one will be dice 2. Die 2 will equal random. The same thing. It's going to be, both of these are going to be a random number between 1 and 6, including the endpoints. And so our roll, that will be a new variable, will equal die 1 plus die 2. Those will be the sum of the 2 dice that we roll together. So next we can do is roll.append and take that value and append it to our list. We're going to take the roll value, which is the sum of 2 dice, and append it to our list called rolled in past tense. And then we can print roll just to get an idea of what's happening, and we can also create a count value, because each time we're going to increment count because each time we've rolled it, because what we want to do is get the final count. Now, many times we're going to have duplicates. We might roll 7 multiple times, in which case we are not getting all possible combinations. So this is the basic idea. And finally, at the very end, after we exit the while loop, we want to print the total count and see how many times we've rolled. And so let's go ahead and run this code and test it. I don't think it's quite right, but it's going to at least give us a starting point as we go through. And that's often the approach that we take to coding, is you get some ideas, you start fleshing it out, you start developing the ideas, and then we can test our basic code. So let's go ahead and clear the screen, and let's go ahead and run our code, and we're going to run demo2.py. And here we go, we get the count is 12, and we rolled it again. And even though we're getting duplicates, we can see that we were expecting the idea that you would get 2 all the way to 12 and 12 rolls. doesn't quite make sense. So we know something's wrong with this code, but we've gotten a start here. We've got a couple dice. And the main idea that we're missing here is that we only want to append roll to rolled if it's currently not in there. So if I get a duplicate the first time I roll 7, that's great. Let's append roll to rolled. But the second time I get it, I shouldn't append it because I've already rolled it. So lines 12 and 13, they ensure that whenever we're appending something to the rolled list, it's always unique. So now when we execute our code, we get 29 rolls. So this is a little bit more realistic. Let's run it again, and we get 40 rolls, and let's run it one more time, and we get 86 rolls. So this is more realistic that when we roll dice, it's going to be far more than 12 until we get all possible combinations between 2 and 12. So let's change one other thing. Let's instead of printing out roll, each roll that's going to be a number between 2 and 12, let's actually print out rolled, which is a list of all combinations that we've already rolled in past tense, and let's sort it and see what we get. And when we run this, we get an error. And this is a common error whenever we're working with the sorted method, because the sort method, instead of being sorted, it actually should be sort. And in this case, when we roll it again, we get let's clear it out and run it again, and we get none. And this is common because the sort method actually acts on itself. So we need an extra step here. So if you ever get none, that's because the sort method doesn't return a value. And so what we need to do is put this in the line beforehand. Let's take the rolled value and let's sort it. And now that's going to sort it. It will be in the correct order, and now we just have to print it. So this will give us something a little more tangible, and when we run this code, it will look a little cleaner. So let's go ahead and clear the screen and run it again, and we get what we're getting is each past tense roll. So we can see on the last time, number one, first it took 39 rolls, and the last thing was the one that was missing, and we have 2, 3, 4 all the way. What was missing was 10. So 10 was missing, and once we get 10, that's the final one to complete the final roll, the final combination. Usually it's going to be something on the ends like 11 or 12 or 2 and 3. So let's run this again and see what happens. And this time the final one, the one that was missing at the very end, was 2. In summary, we've designed a simple algorithm to run a simulation to see how many times it takes to roll 2 pairs of dice and get all possible combinations between 2 and 12. So we've learned about random numbers, we've learned about lists, we've tested for membership within that list, and we've displayed lists out when we've looked at the sort function within lists, and we've designed a simple algorithm. So go ahead and experiment with your own simulations, design your own algorithms, and look at the homework problems. This is zebracode.io.